part 6.3. It involves the solving of systems of equations by substitution. So this is something that you would have to do if you were not given a graph and you couldn't solve the system by graphing. For question 1, you have two equations. Y equals 3x plus 2 and 2x minus 4y equals negative 18. So for solving by substitution, one thing you would have to do is isolate one variable for one equation. And here they have done that for you. They've isolated y, and they're telling you y equals 3x plus 2. So once you've done that step, or once you've realized that they've given you that step, you have to plug in the right-hand side of the equation for that variable. That might not make a lot of sense, but I'll show you examples. So here they have y equals 3x plus 2. So you would substitute this 3x plus 2 in for this y over here on the second equation. So 2x minus 4 times 3x plus 2 equals negative 18. So I just substituted this 3x plus 2 here for y. And now you can solve for x. So I'm going to first distribute this negative 4 here. So you have 2x minus 12x minus 8 equals negative 18. And then you have negative 10x equals negative 18 plus 8. So negative 10x equals negative 10. So x equals 1. And there you've already solved for x. So now this part is really easy. You can just take this solution and put it into either of your equations for x over here and then solve for y. So you can do y equals 3 times 1 plus 2. So y equals 5. So those are your variables for the question number 1. I'm going to also do question number 2. So question number 2 is very similar. They have given you y, and it's telling you y equals 7x plus 15. So here I'm going to take this 7x plus 15 and put it in for y in the other equation. So that's going to look like 5x minus 2 times 7x plus 15 equals negative 21. So here I'll do the same thing. I'm going to distribute the negative 2 here to the 7 and the 15. So 5x minus 14x minus 30 equals negative 21. So negative 9x equals negative 21 plus 30. So negative 9x equals 9 and x equals negative 1. And now that I've done that, I can take this negative 1 and put it in for x in this equation over here. And that gives me y equals 7 times negative 1 plus 15. So y equals negative 7 plus 15. So y equals 8. And that's how you would do those two questions. Sometimes they'll give you fractions, which are not that much different. You just have to multiply the whole equation by the base of the fraction so that you get rid of the fraction. And that way it's a lot easier for you to solve. You also do not have to do this. You can solve the equations With the fractions, it's just a little bit harder. So I would first multiply the whole equation. So this is x plus 3y equals 18. So that's how you would get the first equation. Then for the second one, I'm going to multiply by 4 because that's the largest denominator. And that's going to get rid of the fractions. So 2x minus y equals 8. So that's what your two equations would look like. I'll let you do the rest of those. Hopefully that helps. Another way of solving systems of equations is by elimination. And for me, this way is a little bit harder, but you can decide which one you prefer. Usually, for this curriculum, they would ask you to know both ways, so you do have to know both ways, and then on a test, they'd ask you to do either by elimination or by substitution, so they want to see that you can do both ways. So this is the other way to do it, and this is by elimination, and this requires that you have one equation with some term, and then the other equation will have the opposite sign of that term. So here, for this problem, for problem number 1, it has negative 3x and 3x. So that's what you want. You want one term that'll be positive and one term that'll be negative, and then the rest of it will be the same. So negative 3x and 3x is good. And then you add the two equations together. So negative 3x and positive 3x are going to add up to 0, which is why this way works, because you're getting rid of one of the variables and then you can solve for the other one. So here this is going to equal 0, and then you add y and 4y together, that's going to be 5y, and then you add 30 and negative 15, that's going to be 15. So y equals 3. So that one's pretty simple, and then you can take this y equals 3 and put it in here for y. Either one of the equations works, so you can put the y into the second equation or the first, it doesn't matter, it'll give you the same answer. So 3x plus 4 times 3 equals negative 15. So 3x plus 12 equals negative 15. 3x equals negative 15 times 12. So that would be negative 27. And then negative 27 divided by 3 is negative 9. So that's how you get your x and y variables for that. I'm going to do another problem, number 2. For this one, they're giving you 2y and negative 2y. So the problem is already set up for you, and you can add the two equations together. So 3x minus 2x gives you just x, and then plus 0 equals negative 5 plus 2, which is just negative 3. So x equals negative 3. And then you can take this x equals negative 3, and you can put it in for x over here. So 3 times negative 3 plus 2y equals negative 5. Or sorry, negative 5. And then you solve for y, so negative 9 plus 2y equals negative 5. And then 2y equals negative 5 plus 9. 2y equals 4. Y equals 2. So those are your solutions to that problem. Here for this problem, they're asking you to solve the following system of equations by first eliminating the fractions. So to do that, you're going to do exactly what I mentioned before. You're going to multiply this whole equation by 2, which is going to give you x plus y equals 14. And then here they have 3x plus 2y equals 48. So here you can see that you don't have two terms that are the same but opposite, which means that you would have to rearrange the equations yourself to do that. So you can decide what you want to get. You can either get a negative 2y so that you can cancel this 2y over here, or you can do a negative 3x and get eliminate this 3x over here. So to do that, you would either have to multiply the first whole equation by negative 2 or by negative 3. I'm going to do negative 2. It doesn't matter what you choose. So negative 2. And then that'll give me negative 2x minus 2y equals negative 28. So that shows you that you can now eliminate this positive 2y over here. So now you can add 3x plus 2y equals 48. So negative 2x plus 3x equals x. And then plus 0. And then 48 minus 28 gives you 20. So x equals 20. And then you can take this and put it in for x over here in the first equation that I solved. So that would be 20 plus y equals 14. Y equals 14 minus 20. So y equals negative 6.